We're trying to solve an unexpanded cubic equation today. Now notice if you did expand it out, on the left-hand side you would get 750x cubed as your highest powered term. It's a degree 3 cubic equation. So there's something called the rational zero theorem where you can take the divisors of this and the divisors of the constant term, then write down a list of potential rational zeros. That's not the way to do this problem. Now we are looking for a number that is a real life fraction. By what I mean by that would be something like this: 8 over 3. Okay, 8 over 3. You guys may have seen this notation. Q backslash z means a rational number that's not an integer. Okay, for example, 8/3 would be a member of Q backslash z. Okay. You know, just what most people mean by a real fraction, right? So that's a z. Just to be clear, 8 can be written as 8 over 1, right? Well, to me, that's kind of a fake rational number as far as the type of problems I'm interested in here. So 8 over 1 is not a member of Q subtract z. And really, it's called set theoretic subtraction or set difference, I think, okay? So again, we're not looking for an integer solution like this. We're looking for a real life fraction, okay? Now, so let's take a look at what we have here. Now, this particular, again, it's factored, but we don't have 0 on the right-hand side, so you really can't make much use out of this. And you could get busy right now trying to solve it, but I think it's better to try this substitution u over 5. If you let x equals to u over 5, the given transforms to a much more tractable equation, namely 3u minus 1, 2u minus 1, u minus 1 is equal to 231. Now you're wondering, well, what good did that do? Well, it made the computations a little bit easier, and let me show you why. You can write 231 as, 11 times 21? 11 times 21 is 231. All right, that's because 10 times 11, 10 times 21 is 210, plus another 21 is 231. Now you can write this as 3 times 7 times 11, since 3 times 7 is 21, so you can write this as 3 times 7 times 11. Okay? Now you see, it gets kind of easy in a hurry here because notice that u minus 1 is the smallest of the factors, right? So what do we need? In other words, let's see, is this pointer working okay? Not so well, but anyway, y'all, u minus 1 is the smallest factor, and so that would mean that u minus 1 would have to be, let me write this, u, and you could work with any of the factors, but u minus 1 has to equal to 3. Remember, the prime factorization is unique, right? So u minus 1 has to equal to 3 here. Okay? And that certainly implies u is equal to 4. And you can try that with all the others. You can see it works out nicely. In a similar fashion, 3u minus 1, and again, this is unnecessary, but just to show you, 3u minus 1 would have to be equal to the largest of the numbers in the prime factorization, which is 11. See, and once again, you get u equals 4, right? 4 is a solution to this, right? So we know just like that u is equal to 4, and our answer will be 4/5. 4 over 5 is the solution, ladies and gentlemen. And notice that is a member. Again, I like this notation quite a bit because there's confusion a lot of times if you've ever taught. Kids want to know what a real fraction. Well, this is what most people would think of as a real fraction. It's the rational numbers minus the integers. Okay, like that, and that's the notation. Sometimes I actually use a minus sign for set subtraction. Now, you may want to you could take the time to check this if you wanted to. 15 times 4 over 5 would be what? 15 or 12. This would all work out. You can check it out. 11 would happen right here if you put 4 over 5. If you put 4 over 5 in right here, now if you put 4 over 5 in right here, you get what? 8. Let's see, 4 over 5 times 10 is the same as 2 times 4 is 8 minus 1, so this would be 7. And of course, this would be 3. All right. So it's an easy check in the original equation. And y'all, this substitution wasn't absolutely necessary. You could actually just note the prime factorization from the very beginning, but then it'd be a little bit more trouble to work with these slightly larger numbers. So the substitution is not necessary, but I think it's a worthwhile step. But anyway, that is the solution. So we get x is equal to, we had here, x is equal to 4 over 5. Okay, thank you all for viewing.